All right, I just want to touch base over what we did yesterday in class for some people who weren't here. All right, so we watched a video or an animation that showed a car driving so many miles per hour and then stopping, and then driving a little faster and then stopping, and faster and stopping, and so on. So I'm just going to fill out this chart. 10, 20. All right, so the car started with 10 miles an hour. That was its first speed from when it stopped. And it went all the way up to 80. And this was the information that was given to us. So this is just a sketch of what the graph looks like. Okay. All right. So we want to use the table to record the data that was shown between the speed of the car and the length of the skid mark. So plot the values as you record them. So yesterday in class, we determined that from 4.76 to 19.05 was a difference of 14.29. Okay? From 19.05 to 42.86 was a difference of 23.81. Okay? Now, 42.86 to 76.81 was 42.86. 76.19 to 119.05 is 52. Oh, man. Hold on. There it goes. 52.38. All right, so you just find the difference between each thing. So we know two things. We know it is not a linear function because the graph is not a straight line, and it doesn't have a constant addition, meaning it doesn't go up by the same thing every time. And it's not exponential because it doesn't have a constant multiplication. So the only thing that's left is a quadratic. So remember, quadratic means the second difference is the same. So these numbers right here are our first difference. Our second difference would be saying 52.38 minus 42.86, and that's another common difference of 9.5. Okay, if we take 23.81 and we subtract 14.29, we also get 9.5. So since our second difference is the same, this is a quadratic function. So, number 2 says, based on the graph and the data, what type of function might model the relationship? Well, quadratic. And that is because the second difference is the same with the value of 9.5. All right. Next, on number 3, we wrote up at the top, inverse equals swapping x and y. All right. So you literally swap X and Y, guys. Remember, on number 1, our speed is our X, and our length of our skid mark is Y. Okay? But on number 3, our X is our length of our skid mark, and our speed is our Y. So all I'm doing is I flip-flopped all of my values. Okay. Now, this is my X. This is my Y. So my speed, all right, 10, 20. So here all I did was swap the axes, okay? So my graph is going to look something like this. Here. Then here. And then here. And then maybe right here. 60 is... we got something like this. All right. So all it does is flip-flop my values. All right, 4 and 5 is the definition. All right, you can write that down. You should already have that down, actually. All right, let's go to number 1, 2, 3, and 4. So we drew a chart, and we had M for minutes in a month, and we have T for our total. All right, it says, suppose your cell phone plan charges a fixed rate of $10 per month. So no matter what, you're going to spend at least $10. Plus 7 cents per minute. Create a table. So if we go over an extra minute, that's going to cost us 7 more cents. We have 10:07. If we use 2 minutes, 10:14. If we use 3 minutes, 10:21, and so on. Each time you're just going to add 7 cents. Number 2, write a function rule that models the situation. Well, we're going to have to use slope-intercept form. So, M equals my slope or my rate. Okay, so my rate in this case is 7 cents. And my y-intercept is where I start at 0, so that is 10. Okay, this is our function rule. Number 3, use the function rule in number 2 to determine what your bill would look like if you talked for 100 minutes. It's going to cost me $17, okay? Next, instead of giving our minutes, we're given our total. And we're using the same function rule. But our total is $31. So I'm going to subtract 10 from both sides. And then I'm going to divide by 7 cents on both sides. So X is 300 minutes. So I can talk on my phone for 300 minutes and only spend $31. All right, you're supposed to do 5, 6, and 7 for homework. I'm going to check when you come to class tomorrow. All right, it says complete the table to show the inverse. Remember, all we're doing is swapping. Originally, my minutes were my X values and my dollars were my Y values. But when we swap, my dollars now become my X and my minutes become my Y. And we skipped over to number 17 and 18. So I'm only going to work number 17. I'm going to work number 18, I think. It don't matter. We'll work 17. All right, find the inverse function. Y equals 5x minus 10. First thing I must do is swap x and y. So first thing I'm going to do is add 10 to both sides. I tricked you yesterday, and y'all thought x plus 10 was 10x, but really, it's just x plus 10 equals 5y. I divide by 5. I divide by 5, so I can have x plus 10 divided by 5 equals y. Or I can say 1 over 5x plus 2 equals y. Either one is correct. This is the simplified version. Okay? All right. I want to go to number 21. Find the inverse of this function. Oops, my bracelet. First thing I must do is swap the x and the y. Then, I'm solving for y, so I'm adding 12 to both sides. X plus 12 is literally x plus 12. All right, some of this right here tripped some of you up yesterday. So, I got a fraction. I want to get rid of that denominator. 3 and 5 are dividing. The opposite of dividing is multiplying. So I'm going to multiply by 5 on both sides. Okay? This becomes 5x plus 60 equals, what happens to these 5s? They cancel because one is on the top and one is on the bottom, so I'm just left with 3y. Dividing by 3 on both sides, and I'm left with 5x plus 60 divided by 3 equals y, or I'll simplify 5 over 3x plus 20 equals y. Recording.
You coming to lunch?
Yeah. Sorry, that was the cello inviting me for lunch again. All right, I think that's really all we talked about yesterday. So come in tomorrow with your work done.